For small value of t, show that sine t is approximately equal to t. So first thing, the moment we see this approximate sign and we say very small values of t, I'm going to write down my approximation formula. So I'm going to say f at x0 plus h is approximately f at x0 plus h times the derivative of x at 0. Okay, what we're going to do now is we're going to define ft and the derivative. Now, before I choose values, I'm going to say let ft, because this is the function. So I'm going to say let ft equals, and I'm going to write it down here. I'm going to say let f at t equal the sine of t, that function, sine of t. Therefore, the derivative of t equals the derivative of sine is the cos of t. Right, so I had to define ft and then find the derivative. I find the ft in terms of t over here. The other thing that I have to do now is I have to decide where do I start. So find values for x0 or for xo and h. Now I'm going to choose o because if I say the function at 0, it means I'm going to substitute 0 into ft. If I choose any other value, it's going to be very hard to do it without a calculator. So what I'm going to do is I'm just going to say let x0 be 0. And remember we said h is a very small number. They say where the small value of t. So I'm going to say and let h equals t, and let h equals t. Now I'm going to substitute this in here. So it's going to be f at x0, which is 0 plus t, is close to f at x0 is 0 plus h multiplied by the derivative of x0. And the derivative of x0 is 0. F equals 0 plus t, and 0 plus t is t, so that's ft. F at 0, now I'm going to substitute this 0 into the place of that, so it gives me the sine of 0. Plus h is t, multiplied by the derivative at 0. So that's the derivative of t. At 0 becomes the cos of t, but t is 0. So I put 0 in the place of t in there. F at t, what is f at t? F at t is sine t. So I'm going to say this equals the sine t equals the sine at 0. Now, you can either have your special triangles, or if you remember your sine graph looks like this. Right, where's sine 0? The sine of 0 is 0, or, yep, it's at 0. So that is the sine of 0 is 0, plus t multiplied by the cos of 0. Your cos graph looks like this. So where's cos at 0 is 1, so that is t times 1. So this shows us that sine t is approximately 0 plus t times 1, which is t. So I've just proved that for a small value of t, that sine t is approximately equal to t. Just quick value, just a quick thing. Where did I find these values? This sine theta, sine at 0, is when I substitute 0 in there, then I get the sine of 0, and I found this value. I found that value this one by substituting it in there. That's where I found those values. Our next question, that was A. Our next question is B. Use this approximation to give an approximate value of sine pi over 8. So we just said, so we say that sine pi over 8 is approximately the same as pi over 8. Okay, approximate. So what is pi over 8? If you use a calculator to do pi over 8, your answer is 0.39. So pi over 8, 0.39. You didn't say sine of pi over 8 on your calculator, you just said pi over 8. Now let's say, what is the percentage error in this approximation? So to find, I'm just going to do it here so I have more space. So for C, the approximation, what is the percentage approximation? So the percentage error will be, what is the difference between the real answer and that answer? In other words, what is the sine of pi over 8? Take away, what is that pi over 8? So the difference between that and that, divide by my original sine of pi over 8. And we're going to multiply that by 100% to get an answer. Okay, so that will be my percentage error. Remember, the error is, I say that this is approximately that. So what's the percentage error? The difference between that and that, divide by what this should be. When I do this, use the full values, don't use these approximate values, and then you have to round down. You can't round up, you have to round down your final answer, and the answer then is 2.6%. So you can say 2.6% is the percentage error when I am rounding.